Everyone, good afternoon. Today I'll be doing encoder and this encoder in computer science. Yes, that means the subject is computer science and that what encoder deals with. So firstly I want to go to define this encoder. So an encoder, you must be knowing that an encoder is a logic circuit. Logic circuit means there is a logic and the circuit, you can draw the circuit. You have heard of the AND gates and various gates. With the help of gates we can draw the logic circuit. And what does it encoder do? An encoder is a logic circuit that converts from where to where? From a number, converts a number from any base. So it can be octal, it can be decimal, it can be any base, it can be hexadecimal. So from any base to binary. Binary, you know, the system of two, that's 0 and 1. So it has maximum of 2 n input lines and n output lines. So it will produce a binary code. Obviously our target is to go to any base to binary, so it will produce a binary code equivalent to the input. So whatever we give the input, equivalent to input, which is active high. Therefore the encoder encodes 2n input lines with n bits. Yes, it is optional to represent the enable signal in encoders, where you will find when we are going to decoders, you will find that enable is very important. Why? That is because there you have the AND case, and if there is an AND case, if any one the value is 0, then the resultant will be 0 for that reason. Now we come to the particular 4 into 2 encoder. So what is the block diagram of a 4 to encoder? So you'll find the 4 is there, so the 4 inputs are there, y0, y1, y2 and y3, and they are been transparent to two output signals, that is a0 and a1. So let 4 to 2 encoder has 4 inputs, y3, y2, y1 and y0, and 2 outputs a1 and a0. The block diagram you find it, okay, is shown in the figure. And then what happens is that at any time only one of the 4 inputs can be 1, okay, in order to get the respective binary code. This is a rule at the output. So the truth table, now we come to the truth table or 4 to 2 encoders. Now I'll show you. These are the inputs. 4 inputs are there. You can find the inputs are over here, y0, y1, y2 and y3, and the outputs you'll find over here. So at any time only one of these 4 inputs can be 1 in order to get the respective binary code. So ultimate goal is binary code at the output. So the truth table you can see over here is shown in the right. And now we come to, from the truth table, now how can you write the Boolean function? So you have already seen that particular table. A1 is equal to A3 plus Y3. The OR gate is there. So 2 OR gates you found, and the output is A1 and A0. So this is a gate. The above circuit diagram, this is also called the circuit diagram, contains the OR gates. Okay, and the OR gates encodes for the 4 inputs with 2 bits. You can find the 2 bits A1 and A0. Now we come to the next one, that is the octal to binary encoder. So now the octal means 8. Okay, so octopus you have heard about 8. So over here octal means 8 to binary. So over here when you get that over here you will find that octal binary has 8 inputs. So you find from y0 it goes to y7 and 3 outputs, that is a0, a1 and a2. So octal to binary encoder is 8 to 3 encoder. You can see if you come to the 2 to the power 3, you will find 2 to the power 3, it comes 2 to the 4, 4 to the 8, so it comes to 8. So 8 to 3 it's coming. The block diagram you can see over here, 8 to 3. So is shown in the right. You can see the, now at any time only one of these 8 inputs can be 1. This is a rule of the previously I told, any one of the 4, now any one of the 8. So it depends upon the particular base. Now in this case it is octal. So in order to get the respective binary code. Now the truth table of the octal to binary encoder. So you know that the octal means 8 will be their input and the binary encoder will be 3. So this is shown. You can see very well a pattern of ones are over here, and you can see over here, and so you don't have to learn by heart. You can understand how the things are going. Okay. Now this is a truth table that you can also draw and write it down, make a note. Okay, then we come to, from the truth table we can write the boolean function from each output. So output is here. So from this output, how you have achieved that A0, how you have achieved A1, and how you have achieved A2, you will be shown. So you have been shown over here how we have done that. You can see y7, where is it? Okay, a2 is here. Okay, a2 means over here we have rewritten this, but this is a2 will represent. Okay, and y7 will be representing this one. Okay, you take into assumption that y6 also will be this one, and y5 will be this one. Okay, and y4 will be this one. So 1 2 3 4, like this it will be taking, and this one after this, that how the particular this encoder forms. Now we can implement this, the boolean function, by using the 4 input OR gate. So we can give the OR gate. I'm telling you, encoders, you have the OR gates. So the circuit diagram over here of the octal to binary shown over here, and you see the OR gates are there. So in case of OR gates, the zeroth value will not affect, but in case of the AND gate, if there is 1 0, then the whole answer will be maybe 0 turned out. Okay. So the circuit on the left diagram contains 4 input OR gate. These OR gates encode the 8 input with 3 bits. Yes, 8 inputs with 3 bits. So it is shown there. Now, what are the drawbacks of the encoder? There are drawbacks of the encoder. For that reason, we have the priority encoder. So what are the drawbacks? So there is an ambiguity when all outputs of encoders are equal to 0, because it could be the code corresponding to the inputs. So when only least significant input is 1, or when all the inputs are 0. So in case of over here also, you'll find if more than one input is active, meaning high, then the encoder produces an output which may not be the correct code. Why? Because, for example, if both y3 and y6 are 1, then the encoder produces 1 1 1 at the output. So this is neither equivalent to the code corresponding to y3 when it is 1, nor the equivalent code corresponding to y6 when it is 1. So for that reason, to overcome these difficulties, we should assign priorities, as I have told, to each input of encoder. Then the output of the encoder will be the binary code corresponding to the active high inputs, which has higher priority. This encoder is called the priority encoder. So there comes a priority counter because of the disadvantage. So you will find a4 to 2 priority encoder has 4 inputs. 4 is there, 4 inputs. Yes, y0, y1, y2, and y3, and the 2 outputs are a1 and a0. Here the inputs y3 has the highest priority, whereas the input, okay, y0 has the lowest priority. Y0, so lowest priority. In this case, even if more than one inputs are 1 at the same time, the output will be the binary code corresponding to the input, which is having the higher priority. So there comes a priority encoder. So it will take only one which is having the higher priority, not all the ones. So we consider one more output. A V is in order to know whether the code available okay, at output is valid or not. So V for valid. So now it's showing there at least one input of the encoder is 1. Then the code available at output is valid 1. In this case, the output V will be equal to 1, obviously. If all the inputs are encoded as 0, then the code available at the output is not a valid one. So in this case, the output V will be equal to 0. So the truth table of 4 to 2 priority encoder is shown below. Just see the priority encoder over here. See, you are eliminating the rest of ones. So if there is one over here, so we are ignoring that. So this pattern is called the 4 to 2 priority encoder. So only one will be taken. See, each line is there. So over here only one is taken. Not all ones will be coming into phase. Okay, and so a 4 variable k map for getting the simplified expression for each output. So how you can use a k map? You have already know about the k map. Okay, so from the k map you can get the values of the you can get the simplified expression for each of the output. Okay, and then so there's a k-map portion. I will also elaborate some k-map portion later on. Okay, so that you know. And now we come to the simplified Boolean function. From there we can deduce, and even we have done that also. So we can deduce. Similarly, we will get the Boolean function of the output v. Okay, as this final value output will be over here, you can simplify it through the k-map. You can simplify it through the Boolean expression, whatever is which feasible for you, and then we can implement the above Boolean function using the logic gate. So you can use the logic gates, and the logic diagram of 4 to 2 priority encoder is shown. Just see, this is the priority encoder. Okay, where all the ones will not be taken, only the priority will be taken. So the circuit diagram contains two input OR gate. Okay, so two input OR gate is there, and you get the two input OR gate, one 4 input OR gate. Okay, and two input AND gate and an inverter. So these is comprising of the particular thing. Here AND gate and inverter combination are used for producing a valid code. So valid code is important at the outputs. So even when the multiple inputs are equal to 1. So if there are more ones, then only one is taken at the same. It cannot come, all the ones cannot come at the same time. Hence the circuit encodes the 4 inputs with 2 bits based, okay, with 2 bits based on the priority assigned to each input. So this is the priority. So hope it's clear, and more I'll make you clear. Thank you. Okay. Thank you everyone. Okay. Hope you like my video. Thank you.